So here is a question of the day, day 1. Topic I have chosen for this week question says Newton's laws of motion. So we'll discuss good questions of Newton's laws of motion this week. Subtopic chosen for this particular question is a spring force, right? So see this question carefully. I will read this question for you first. A block of mass capital M is suspended from a spring of same mass capital M and spring constant K. The other end of the spring is attached to the ceiling of a lift which is accelerating upwards with G by 2 as shown in figure. Find equilibrium extension of the spring. And here I can add one more thing, that assume extension is a small, right? So generally it is not mentioned in the question, and by default we have to take it that the extensions are small. So if extensions are not small, so then it can go beyond Hooke's limit, it can go beyond proportionality limits, so that is a different story. But for all questions like this, by default assumption is extension is small only, right? So if students know this question, means no concept behind this question, still not getting answer, it means it's a big mistake, right? Knowing concept behind a question is important, and solving the question properly with 100% discipline and getting right answer is equally important, right? Because the final thing is getting right answer. Okay, so don't take this question lightly. Don't think it's a easy concept only. I will do this that and I will get answer. No, it's just try to solve it. What answer you are getting, let's see that, and then uh, see detailed solution of that also. Give yourself at least 2 minutes. Okay, so pause this video for 2 minutes and then we'll see what is the solution of this question. So detailed solution I am going to discuss. Okay, so first, just by looking at the problem, we should decide our approach, that in which direction we should think. So spring is there, block is there, so many ideas can come in our mind. One idea can be we can apply work energy theorem. Other idea can be we can write force equation, we can go for force method, and then linear momentum conservation, means many ideas can come. But if you see, this is a single event based problem. So whenever there is a single event based problem, means only one event is described in a problem, then always the best method is force method. Means we should write force equation, or in rotational motion we'll write torque equation, right? So force or torque equations we write to get a particular equation in a given event. So here what is the event? Equilibrium extension of the spring. So that is required. So when block is in equilibrium, obviously with respect to lift, in a lift frame. So here we should not do overthinking, that equilibrium is given, what kind of equilibrium is this, whether it is with respect to ground, with respect to lift. So they are saying equilibrium extension of the spring means the extension of the spring is not increasing, right? So obviously in a lift frame they are asking, when the system is in equilibrium, find extension in the spring. So they are not saying, so you have started the motion and then after some time what is the extension, nothing like that. If question would be framed in that manner, then we have to apply work energy theorem. So here it is very simply said, find equilibrium extension of the spring. Means in a lift frame, what is the extension of the spring? So once we have decided the approach should be force method. We should try to write a force equation on some element in a lift frame, right? And then brainstorming angle also, it's quite clear here that we have to select some element as our system, and on that system what is the force acting. So we'll write force equation and we'll get extension. So that should be our approach and brainstorming angle, right? So now mistake alert. Many times I have seen when I am giving this question in the class, quickly students are giving answer and they are giving wrong answer. So what they are saying, sir, total force on the system in lift frame is equal to this spring force finish, like that they are saying. So obviously here this thing we cannot do. Why? Because the important point of this problem, I have given this question to you, the reason behind it, its crux point, extension in different sections of the spring are different, as spring constant is inversely proportional to natural length, right? So in this spring, because of the spring force, different sections of the spring are experiencing different force. Usually in our questions, springs are massless. So springs are massless means at every point we can see that force is same. But here the case is different. Here force acting at different points is different. So that's why extension in different elemental portions of the springs will be different, right? So what we need to do here, we need to select some element of the system, right? Some element of this system I will select, and I will try to find out extension in any small element of the spring by writing force equation on my elemental portion. So let's see the working part of it, the correct working part. Okay, so in lift frame, I am choosing this system. I have taken at any distance y from the top, I have taken a small section of the spring, right? And below it, the remaining part I have taken as element to write force equation. So I will write force equation of this section in the box. That section I will write force equation. So first of all, uh, just above our element, our system, just above our system, a spring is there having spring constant. I'm taking any small element dy. So for this small element dy, what will be the spring constant? So I can write k dy. So it will be kl by dy, because we know spring constant is inversely proportional to length. So for a particular geometry and material, I can write for a particular spring that k into l is a constant, like this. So like this I can write. So k into L constant. So if suppose natural length of the spring is capital L and its spring constant is k, so then spring constant for a spring having natural length dy will be what? KL upon dy. Means I can write of dy k of dy into dy is equal to k into L. So that we can write like this. So now if I am taking lower part and the block as system in a lift frame, so then gravitational force acting on the block and lower part is total weight, means total mass of block and portion of the spring in our system, m by l into l minus y, g plus g by 2, because lift is accelerating upward. So pseudo force that would be acting on our system is mg by 2, right? So m is what? Say total mass of our system, right? So adding up, so that I am getting total gravitational force in lift frame. It should be equal to a spring force exerted by a small elemental spring above our system, right? So this part. So ky or k dy, you can write your choice into del y. Okay, so now I'm writing this is force equation, and that is a spring force of that small elemental spring. So by this I'm getting a equation of extension extension in the small elemental portion of spring having length dy, means in a dy length of the spring this will be the extension del y. Okay, or I can write this step separately without integration 2kl. So I'm rearranging the terms, so I'm writing this thing. So del y is what? Extension in the elemental portion of spring having length dy. That is the extension. So now we can integrate this term. So I have integrated this term, right? So on integration, so I am getting this answer. Delta y is equal to 9 mg by 4k. So that is my answer. Okay. So that is the procedure that I have followed to solve this question. There can be other method also which is better than this, right? So then please suggest that method in the comment section. I won't mind. So if any student is saying, sir, that is a very long approach, we can solve this question in a single step, and that is how to do. Okay, no problem, right? So it's better to discuss. Okay, so anything coming in your mind, please discuss it in a comment section so that other students should also know, right? Okay, so now one method when I used to give this question in the class, one method that the student generally suggest is, sir, we can find extension in the spring due to its own weight separately, and then we can find extension in the spring due to block connected with it, and then we can add both the extensions to get total extension. Okay, that is also the right method, but for that you need to remember formula of extension in the spring due to its own weight. That formula you need to remember. If you know that formula, then directly by adding the extensions you will get the same answer. Or formula you don't remember, okay, and the extension you are finding for spring separately and adding with the extension due to block, the number of steps will be equal only, right? So any other method is coming in your mind, so please suggest in the comment section. Thank you.